Hey, what's up? It's your old pal, Mr. Cook, and we are working on the 8.1 to 8.3 quiz review. We got through the first four problems that had to do with 8.1. Now we're going to deal with numbers 6, 5, 6 and 5. So those two problems are going to be dealing with section 8.2. So if you need a little bit of additional work on those or some, a little bit of reference back to the notes, just check out the notes on 8.2 for this stuff. So this is going to be broken up into two different sections, one in which we're putting data together based off of a spinner, and then another one where we're putting data together based off of some number sets. And you know what? Now that I look at it, number 9 is also 8.2, so we're also going to do number 9 on this one. So we're going to kind of skip around a little bit, but just to cover all the 8.2 stuff, that's what we're going to do. Okay, so we're first going to list off the sample space. Now, the sample space is going to be all of the possible options that we can get with the given information. In this case, the given information is from this little, I don't know, like a spinner kind of thing. Like imagine that you have like a little spinner that's attached to this, and then you flick the spinner and like spins around and it lands on one of these things. And it looks like they're all equally likely because it's broken up pretty evenly. So let's list off the sample space. If I flick the spinner, one option, the first one that I could get to, and what the arrow points to is a yo-yo. So let's call that Y, yo-yo. And then kazoo, let's call that K. So this is a Y and then a whistle and then no prize at all. Let's just like put letters next to it to make it a little easier. Okay, so my first sample space is that on my first flick, I could get a yo-yo. And then on my second flick, I could get another yo-yo. So yo-yo and then yo-yo, Y and then Y. Now let's see, let's just kind of list off all the possibilities. What if I flick it again and I get a yo-yo? And then I flick it again, what would another option be? I mean, I could get another yo-yo again, but that's the same thing that I just had. So let's do another one. Yo-yo first, and then I get a kazoo next. So yo-yo and then kazoo. And then let's say that I flick the first one, I get a yo-yo. Another option is that I could get a whistle. And then I could get a yo-yo first, and then I could flick it over here and get a no prize. So these are 4 options of 2 spins that I could get. But once I get all 4 of these with the yo-yo first, then I've exhausted all the other options from getting yo-yo first. So let's move on to the next one, okay? So, I mean, if I were to get a kazoo first, what else could I get? So I could get a kazoo on my first flick, and then I could get another kazoo. I could get a kazoo first and then flick it again and get a yo-yo. I could get a kazoo first and then get a whistle. And then I could get a kazoo first and then I could get no prize. So there's 8 different, things that I could get in the sample space. I could also flick it and get a whistle first, and if I got a whistle first, then I could get another whistle on the second try. I could get a whistle first and then I could get a yo-yo. I could get a whistle first and then I could get a kazoo. Then I could get a whistle first and then I could get a no prize. And then the dreaded no prize, of course. And then if I get a no prize first and then I flick it again and I get another no prize, that's one option. I could get a no prize and then I could get a yo-yo. I could get a no prize and then get a kazoo. And I could get a no prize and then get a whistle. So these are all the different options that I could get and the likelihood of them happening. So what's the probability of winning a yo-yo in one spin? So if I just flick it once, the probability of getting a yo-yo, I have one option of getting it here, another option of getting it there. So this kind of goes into the probability sections that we're going to talk about in 8.3, but the probability of getting the yo-yo on one spin would just be one desired outcome. So I'm sorry, no, 2 of them, because we have 2 different yo-yos. So there's going to be 1, 2 out of a total of 1, 2, 3, 4, 5 different options. So 2/5 would be my probability. What's the probability of winning nothing after 2 spins? So like if I spin it once, the probability of getting no prize is 1 out of 5. If I spin it again, it's again a probability of 1/5 to get no prizes whatsoever. So just like with the counting principle from the previous one, what I can do is I can multiply these 2 together because they're independent events. So if I multiply this fraction and this fraction together, 1/5 times 1/5, I get 1/25. So 2 spins, the chances of getting no prize for both of them would be 1 out of 25. What's the probability of winning a kazoo and a yo-yo after 2 spins? So I'm assuming that they mean like in order, kazoo, and then yo-yo. So like the first option is probability of getting a kazoo. So there's one kazoo out of 5, so that's 1/5. And then getting a yo-yo on the second try. So there's 2 yo-yos out of the 5. So you just multiply those together, and then you get 2 out of 25 for the 2 spins. You just multiply straight across. All right, so that's number 6, putting together data and a sample space, and then also sort of some 8-3 stuff, really, because that's probability with that. And I apologize for going a little out of order, but if you need some reference with the probability stuff, that's going to be in the next video when I tackle number 7 and number 8. I thought that I'd do those ones in the next one because we're going to need like the little sample cheat sheet that we have for the standard deck of cards, the fair coin, and the sum of 2 dice. So I'll just keep all that stuff on the next video. Anyways, number 6 is just straight up 8.2. So if you need some reference for that, go back to that section. The first thing that you're going to want to do is probably fill out these little subspaces that you have, or these groups that we have, like A, group A. If they aren't already filled out, like B is already filled out because it tells us all the numbers that are in that. But like this one says the evens. Well, what evens? You get the evens from this thing called the universal set. These are all of the possible numbers that you're going to be working with. So the evens are going to be all the evens from here. So, we've got 2 and 4 and 6 and 8 and 10. So those are all the numbers that are going to be in A, the evens. So let's get familiar with this notation that we have over here. First, the little u. The little u there means the union. And the union is like, think about like what a union represents, like kind of, bringing things together. You might remember like the Union from the Civil War, like it's a bunch of states that came together to fight in the war. So think about it like they're all coming together to make one, okay? That's what a union represents. They all come together and make one thing. So if I take A, the group A, that's the evens, 2, 4, 6, 8, 10. And if I take the group B, which is 2, 3, 5, 8, what I'm going to do is just put all that stuff together, and that makes one big group. So my big group goes like this. I just list off all the numbers, and they have to be distinct numbers. So in other words, even though I know I have twos there, I'm only going to put one of them on there, okay? So like 2 is in my group, in my big super group. 3 is in my big super group. 4 is in my big super group. 5 is in my big super group, and then 6 and 8. And I'm not going to do it twice because I have 2 8s. And then the next one is 10. So these are all of the numbers that are in my big old super group of the union of these two. Next, I have this other little symbol that looks like a lowercase n. That means the intersection. So think about where you remember the word intersection from. All of you guys, or the majority of you guys, are 16 or older, so you might have heard intersection from where 2 roads meet up, the intersection. Where is the intersection? It's right there in the middle where they intersect, where they meet up. So think about intersection as being like where things meet up, or where they have in common, or where they overlap. I like the word overlap to use a lot with that. So the intersection means where do these 2 groups that I have overlap? So the 2 groups that I have are here, and what ones do they have in common, or where do they overlap? So the numbers that I see that they have in common are 2 and 8. So that's what the intersection is. It just asks which one they have in common. So those are your 2 answers, 2 and 8. All right. Next, we have these little apostrophe kind of looking things. That's what we call the complement. So the complement means all the stuff that is not in that. And remember that all of the possible numbers that we're dealing with are just the numbers 1 through 10. So let's start with the first part of it, a complement. So what I would do to find a complement, this first part of it, is I would see what numbers aren't in the evens, okay? So if I knock out 2 and 4 and 6 and 8 and 10, all the evens, all that's left are the odds. That's what this part represents. It's all the numbers that aren't in this group. So 1 and 3, 5 and 7 and 9. Those are all the numbers that are there. And then we're doing a B complement. So if we go over to the same group of all the possible numbers, the universal set, and if we get rid of all the stuff that's in B, so 2 and 3 and 5 and 8, we just list off all the remaining numbers. So 1 and 3, 1 and 4 and 6 and 7 and 9 and 10. Okay, so we do that. We've established both of these individual groups. Now we need to find their intersection, or where they overlap. So what numbers do they have in common? Looks like they have a 1 in common, and a 9 in common, and a 7 in common. So 1, 7, and 9 are the numbers that they have in common. So that's in their intersection. Okay, and then the last problem on number 6. So you need to follow kind of the order of operations here. So you do the stuff that's in parentheses first. And luckily, we've already found these numbers that we're looking at. So A intersection B is the same as this one, which was just the numbers 2 and 8. So this is finding the complement, or the opposite, of the numbers 2 and 8. So what are all the numbers that are in the universal set that aren't 2 and 8? So, just eliminate those two numbers, 2 and 8, and list off all the other ones. So we've got 1 and 3 and 4, 5, 6, 7, and then 9 and 10. So those are all of the numbers that aren't 2 and 8. So again, just kind of reiterate, the reason that I picked 2 and 8 is because that's what that represents. Remember, the A intersection B is just 2 and 8, so that's why that's those two. Okay, the other stuff that's in 8.2 is this Venn diagram stuff. Let me just verify that. I just gotta look over at the worksheet for that. Yeah, Venn diagrams, okay. So 8.2 is also Venn diagrams. So then that's going to be number 9. So let's go ahead and answer number 9 as well. Okay, so you read through the description and fill out your Venn diagram. It says, complete the Venn diagram, label correctly, and put the values in the appropriate places. A school has 600 juniors, so that means that it's a total of 600 students. 150 of them are athletes, 75 belong to clubs, and then 25 do both. Okay, so those are your two different circles that you're going to make for your Venn diagram. It's going to be athletes and also club members. So let's say this is athletes and then club members. So you always want to start with where they overlap. So that would be the ones that the students that do both athletes and also that are both athletes and do clubs, and that's 25 of them. That number that does both goes in the middle here. So that's going to be 25 in the middle. Now, all of the total members of the clubs go in here, okay? So there's 75 total people that go in this circle here, 25 of which are already taken care of there. So if I have a total of 75 that are going into this circle, 25 of it's in here, how many are left over for this spot right here? So the way that we find that is just by doing 75 minus 25, which would be 50. So 50 is the number that goes in here. Now, if you add up all the numbers inside of the club circle, it's going to be 25 and 50, which adds up to 75, which is how many students are in clubs. There are 150 total athletes, so that's 150 students that are going to go in this circle. So 25 of which are in here. So the way that we find out the number of students that are just athletes and not in clubs is that we take the number 150, which is the total number of athletes, and subtract away 25, the number in the middle, and that gives us 125. So there's 125 students that are only athletes that aren't in both athletics and clubs. So now for the last number, and that's to figure out like what number goes on the outside, which would represent the number of students that are not athletes and are not in clubs. So the way that we find that is we add up all these numbers, so 125 plus 25 plus 50. So what is that? That's 150 and 50, so that's 200. And then we subtract it away from the total number of students. So there's 600 total students. 200 of them are in these two things right here, either athletes or clubs, and we get 400. So that means that there are 400 of those junior students that are not in athletics and are not in clubs. Okay, so we've set up our Venn diagram. That's all the information that we need because we got the stuff in the middle, the stuff outside the middle, and then the stuff outside the circles. So now let's answer the questions. It says, how many students are in athletics or in a club? So are the students that are just athletes, athletes? Yes. What about the ones that are in athletes, or that are athletes that are in clubs? Are they athletes or in a club? Yes. Are the students that are just in clubs in athletics or in a club? Yeah, because they're in clubs. So it's all three of these things here, and then we just add them up. So we've already done that over here. We ended up with 200, so 200 would be our answer if we add up all three of those numbers. How many students do not belong to either athletics or clubs? So are the students that are in athletics in either athletics or clubs? Yeah, all these students are in either athletics or clubs. So it's just this number out here, the ones that aren't in the athlete circle or in the club circle. So that's going to be 400 students. How many students do not belong to a club? So are the athletes that are in a club Are they in clubs? Yes, so we don't count them. What about the people that are just in clubs? Yes, of course. But then the athletes that aren't in clubs, and then also the students that aren't in clubs or in athletics, both of these groups aren't in clubs. So we're just going to add those together. 400 and 125 gives us 525. So there's 525 students that are not in clubs. Yeah, so that answers the questions based off of the Venn diagram. And it also completes the parts that are in 8.2. So if all of that stuff made sense to you, cool. If some of it was kind of a little bit confusing, just make sure that you go in and talk to your teacher, just get some insight or revisit your notes or work on some extra examples. There's also like some really good videos elsewhere like Khan Academy that goes over all of these topics. So, just make sure that you check out some of those sources because this can be a really easy topic. You just need to kind of make sure you check all of the things that you can. All right, that's it for this video. On to the last part, which is going to go over probability, which goes real fast, and that's 8.3. Okay, on to the next one.